let's go ahead and get started. I hope you've all had a pretty good day. My Thursday's been a little crazy, but that's alright. Sorry, it's a bit of a late start. But I was thinking about ending the stream early today anyway, so I guess it all works out. But let's go ahead. Today I'm going to start on our shader series, and today I want to try to replicate this sparkle shader made by Twitter user at Boba Cupcake. So yeah, he was nice enough to make this little image tutorial about a cool little sparkle effect you can make in Unity. So it looked fun to me, so I thought I'd go ahead and experiment with it on stream. But yeah, be sure to go at least like this post or give him a follow. In fact, I guess I'll retweet this now. But yeah, again, that's at Boba Cupcake, and thanks again for the nice little image there. So I guess first off, let's do some setup before we get into the fun part. So I've already created a Unity project here, and I've downloaded the lightweight render pipeline, which I try to make all my games using that now, but just because it's going to be the default pretty soon in Unity, so might as well get used to it. It has a few differences with the old standard renderer, so it's it will be useful to get wrap my brain around it. But in order to enable the lightweight render pipeline, you need to go into your asset window and create rendering lightweight render pipeline and then pipeline asset. I'm just going to call this the render pipeline, or I'll just LWRP for lightweight render pipeline. And this asset you can use to set different options for the renderer. I'm going to just go ahead and leave the defaults for now. But it's still not actually active in the game. In order to activate it, you need to go to your player settings or project settings under edit, and then in graphics, where it says scriptable render pipeline settings, you can just select your asset, and then now it is enabled. Alright, so I'm gonna create some folders here. Models. Textures. Oops. Okay, there we go. Accidentally created that in the wrong folder. And then a shaders folder. So obviously, if we're going to do anything with shaders, we need to have some kind of model. So I already have Blender open, and I think I'll just make a nice little sphere. Test things out. So in Blender, you can press Shift A to bring up the add dialog, and I'll say add mesh and icosphere. This is Blender 2.8, by the way, which has a much different layout than the older versions. It took me some time to get used to it, but overall I think it's better, so let's see. Well, let's make a few different spheres, I guess, that we can test with. So this will just be a very low poly. So we'll save this as oh, well, before I go any further, I think I might need to set up UVs. I don't know how that is. Okay, well actually that's not too bad, so maybe I'll just leave it at that. You could probably distribute them a little better, but I hate UV editing, so I'm just going to leave that how it is for testing. So this is the wrong folder. Oracle shader, assets, models. Let's call this icosphere 1. This has one division. And then I'll make a smoother one. Oh, I need to go back into object mode, and then I can press delete to delete it. And again, Shift A to add icosphere. And then let's bump it up to 3 subdivisions so we'll have a nice smooth sphere. And now I'll save this as icosphere 3. Okay, so now if I open the project back up, it should import them automatically. And just bring them into the scene. There we go. So right now they obviously just have a plain white material, but I'll just leave it at that. Now one thing that I saw this needs is it needs a noise texture, so I guess I'll go ahead and make that too. So I have the Gimp, which is just a free Photoshop-like program. So we'll want to create, oh, I guess it's new. Let's see, how big do I want it to be? Let's go, I don't know, 1024 by 1024 sounds fine to me. And I think it's been a bit since I've done this, but they do have a noise filter. I think, yeah, RGB noise. Then you just gotta kind of pick values that look good. Although it doesn't seem to be doing anything. Oh, maybe it's because the random seed is 0. Because it's not actually doing anything to the background, so maybe it doesn't work with white. So I'll add a new layer. Is this transparent? Well, I don't know why a transparent would work. We'll just have to see. Okay, so this isn't doing anything either. Let's see. Maybe if we do like a neutral gray. Lightness 50. And then fill this. We got paint bucket. Oh. Maybe it's the render. Oh yeah, maybe I should have gone to render noise. I don't really want... Yeah, I don't really want something with a pattern like this. I'd rather it just be random noise. Okay, so there... I guess we had to start with something. If I set these to be 1... Okay, so that's, I think, more what we'll want. This noise texture is a lot lower resolution, but it shouldn't really make a whole lot of difference. And if it does, we can change this texture. Navigate down to the assets folder, texture. Oh, actually, I don't want to save this. Oh. Yeah, I was going to say, usually you can't actually save a file in PNG. You have to export it, which is kind of annoying. So it's probably going to make me find that folder again. Okay, so now I can save it as a PNG. Let's just call it random noise 1024.png. Okay, I think the default should be fine. And now if we open it up in Unity, yeah, it exported okay, except I don't want it to have a color texture. I mean, I want to mark it as sRGB. I mean, as not sRGB, because we're going to be using it as, I guess, a texture in computing, and it's not actually going to be shown. So in other words, the data on the texture is not actually like a color that will be displayed. It's going to be used in part of an algorithm. And then I don't want bitmaps either. And a point filter. Okay, so now we're ready to actually get to the shader. So we'll create... So in the lightweight render pipeline, it's usually best to start with the unlit shader. And when you double click, it'll open up Visual Studio for us. Hopefully this won't take too long. Let's see, so the main idea of this shader is, yeah, we have this noise texture, and for every place on, I guess for every pixel, we compare the noise texture and kind of use it as like an offset to the normal. And then if the normal and the view vectors are very close to one another, then that means that we'll want to output like a brighter color there. So it'll be kind of like a speck of light, or a sparkle, in other words. That's the main idea. Okay, so again, shaders are kind of scary when you first see them, but I'll try to break down a lot of this. And let's just call this Edmix Games Sparkle. And in case this file ever gets shared somewhere, I'm gonna go ahead and put a link to this tweet. Shader inspired by Twitter user at Boba Cupcake. Okay. So the properties here, we're going to need something to point to the main texture of the object, and then we'll also need the noise texture. I'm also going to fix up the brackets and indentation. Okay, so what else? I think... Let's look back at the tutorial. Oh yeah, so the scale is basically the scale for the noise texture. And then the intensity is like the, I guess, the intensity of these flicks of light. So what I always forget the syntax for this. Yeah. So it's the name and then the type, which is this float. And then noise intensity. I'll just default that to 1 as well. Okay, so these properties are what we allow the user to edit, and it kind of, well, not kind of, sorry. Oh, my allergies have been bad, but what I was saying is it determines what the fields are that the users can edit in any material using this shader. Let's go ahead and create a material now to show that off. Sparkle. And then our shader will show up under Ned Makes Game Sparkle because that's what I named it right here. So this kind of determines where your shader shows up in that dialog. So yeah, we have a field here for texture. Oops, and I forgot to name this, but this is the noise texture. And then we have noise scale and noise intensity. Then these are some default properties that show up for any lightweight render pipeline texture, but you can kind of ignore them for now. So noise texture, I'll call this the albedo because that's the standard name for that. The base color of a object. Okay, so the sub shader, basically a shader can have like multiple, I guess, sub shaders or like sub programs that can run under different times or different conditions. But for now, we're just going to have one sub shader. And then the pass is also something similar. So say you had one pass that you rendered the base color for an object and then another pass for lighting. But again, we'll just need one pass for now. And then CG program, I should actually change this for lightweight render pipeline. I think it's H. I wonder if I have that wrong. Let's see if it throws an error. Okay, no. Yeah, they changed the programming language that you use to write shaders in the lightweight render pipeline from CG to HLSL, but they're basically the same. To tell you the truth, I'm not sure exactly how they're different, but... And then, okay, so these pragma fields tell Unity which functions to run at different times. So the vertex function runs on every vertex of your mesh, and it kind of lets you calculate values that you can blend between for every pixel on the triangle. And you want to try and do as much as you can in the vertex program because obviously it's not going to run as much as, well, the fragment program, which runs on every pixel. So the fragment program you want to try and make as efficient as possible because it's going to be running a lot. That's basically what those two lines mean, and then this just makes Unity's default fog work. I guess I'll leave that in, although we're not really going to be using it. And then Unity CG is... actually, yeah, we won't be using this because we're going to use the lightweight render pipeline. I should... forget. Yeah, the lightweight render pipeline has a different include file, but I can't remember. Oh, I know what, I can just look at the default lit shader. Okay, so this is the default shader for lightweight render pipeline. Obviously, it's a lot more detailed, but mostly I just want to see what they include. Okay, well, this actually doesn't help me too much, but I'll look at this lit input. Oh wait, what was it? Shaders, lit input. I didn't see that in there. Oh, yeah, it's right here. Okay, so this includes the core, so maybe that's what I wanted. Yeah, so shaders, you want to try to use as much of the default functions that Unity provides, but you kind of have to do some digging into the shaders to find that out. So I'm just kind of looking in here to see what functions I might need to use. So they have this sample normal. Oh, that's to get a normal from a texture. Let's look. I'm just gonna look online to see if there's like a simple lightweight render pipeline shader. Okay, so I see here, it's mostly just talking about the default shaders. It's not really telling me how to write my own. Okay, so this person has like a template, which is nice. I mostly just want to find out. Okay, yeah, so they include the core. And then lighting. So I probably will need some of these. Okay. Yeah, I haven't actually written a lot in the lightweight render pipeline. And I didn't think about all this like background stuff I might have to deal with. But I did want to learn it, so I guess it's worthwhile. I'm just not sure. Yeah, I just forgot that I'd have to think about it all. Let's just make something simple, and later on I can try and convert it to work with all the bells and whistles. Okay, so this app data is a structure, and basically it's passed to the vertex function. And then the v2f structure is passed from the vertex function to the fragment function. Is the basics of it. But since a fragment is a pixel on a triangle between three vertices, it's everything that's in this V2F is interpolated between the 3 vertices so that it's the correct value for the specific pixel. Okay, so I know that this should be different because of doing our screen capture transition shader the other day. Maybe I should just look at that. Yeah, so we have this that we can use as to help us initialize a texture. And then I'll also set one up for the noise. Yeah, so for any attribute, Unity will look to see if this value matches up with some function in the path of a shader, and if so, then it will set the input value to this variable automatically. So I can just declare a float for noise scale, and then a float for noise intensity. Okay, so I'm not sure. Okay, let's actually just apply this very simple shader. Doesn't really do much, but in fact, I think I'm gonna get rid of this fog because I'm not gonna use it for now. Maybe I'll just comment it out. But it's just going to complicate things and I don't need it. So this, all it does is convert the vertex, which is the position of this vertice on the mesh, from the mesh's coordinate system to the world coordinate system. Or actually not the world, it converts it to the camera's clip coordinate system, which is kind of like its view of the screen. And that way we can figure out the pixel that will be inside any triangles attached to this vertex. And then this does the same thing for the vertices UV, which is, if you've done any modeling, that's kind of like that vertex's place on the texture. No, not right now. So if anybody has any specific questions, feel free to answer. I mean, I'll feel free to answer them. But it's a big rabbit hole for 3D modeling, so I don't want to spend too much time on it. Texture sampler. Okay, yeah, I probably forgot the include file, or the include directive for that. Okay, so that's the standard library for post-processing, so maybe I don't want to use that. Let's see this. Okay, interesting. So this document maybe already is set up with some information that I can use. Before, a lot of this was out of date because it was the old rendering and not the lightweight render pattern or render pipeline. Kind of seems like it's still not been updated, but maybe they have use the same naming. But this is the, well, I do want to use the core lightweight render pipeline functions. Let's see if it throws an error. Okay, yeah, so it still doesn't know this texture 2D, sampler 2D. see. I wonder how they declare a texture here. Because there's plenty of textures. That's interesting. So they have the fragment function, but where do they declare the textures? Oh, that's global illumination. This is like the lighting. Am I just missing it? I don't see... Actually, I don't see a declaration for any of these, like the base color. Maybe that happens in one of these includes. Everything is included in the core. Include the SOP shader library, all constant buffers not related to materials. Also includes matrix space lighting. HLSL will include the light functions. That's fine. I'm not going to worry about lighting for now. Although, well, actually, we probably will want to add it in. Include. Okay, so it looks like I need to look in here. Oh, the lit input. So this is what imports all of the variables. Yeah, if you haven't worked with like C++ or some other programming language that has an include directive, when you call this, it basically just copies all the text from this file and places it right here in your program. So you can do a lot of, I guess, scripting magic with that. So that's why there's not a declaration for the shader, for the texture variables here in this file. Instead, it's like hidden away in the lit input. So let me open that up. Did I already? Oh, okay, so yeah, it doesn't even really have a special way to do it. You just call texture 2D. So I guess it was staring me right in the face. That's alright. I don't really like having it on the same line like that, so. Alright, so now let's see what other errors I have. Yeah, so Unity object to clip position is broken. Probably this function has changed names. So let me look in the core and see if I can find it. Let's get camera position. Hack normals. Cute. Maybe I should just look in that template I found. So get vertex position input. Needs a position in multiple spaces. The file will strip all the unused references, so if you don't need view space. So therefore you have more flexibility at no additional cost. Okay, so that's just kind of interesting. What this is, yeah, the shader compiler is very smart. So if you have unused fields in a structure, the shader compiler will actually go and just remove those fields and also remove anything that would like define those fields and figure out the values for them. So that's why you can get away with calling something like this that might like set up extra data that you don't actually use without slowing down the shader. So I'm going to go ahead and use these standard names for the structures as well. So it seems like they like to put attributes for the app data, which makes sense, and then varyings for the fragment input. I'm going to go ahead and use that same naming scheme. And then input. Okay, so this is a couple other interesting values here. I wonder, do I need to use these standard names? But I guess I might as well. I'm not sure. Oh, its position in object space is the OS. So yeah, we have the position of the vertex, the normal of the vertex, the tangent, the UV, and then this UVLM. Oh, the UV for the light map. I don't think I'm gonna worry about light mapping, so I'll just leave this here. And this input instance ID is for batching, so I'll leave that, I guess. I don't think I'll need the tangent. We will need the normal, so. And then your UV, position, world space, and fog factor. Okay, so this is where they have the position for this vertex in world space, plus like a fog multiplier if you're gonna have fog for like distance, but and then if you have a normal map, we're not gonna use that kind of stuff. So the normal in world space, I guess we will need that. Okay, and then the position in clip space. Yeah, I was looking for that. Yeah, we're just gonna need the UV and then the normal. I don't think we'll need the world space position for our sparkle shader. Okay, so let's see, how does this shader, so normal inputs, does something similar for the vertex, but then also gives us our normal information, so. Okay, so it's interesting, it needs the tangent. I wondered if we don't have a tangent, so I wonder if I just sent 0, how that would work. I guess I can look and see it in here. Let's look at this code. Get vertex normal inputs. Just this current document. Okay, so actually there's a version without the tangent. Which makes sense. We really only care about the normal world space because we're not going to have a normal map, so the tangent and the bitangent's not important. Yeah, this file is being very helpful. Because last time I tried to do all this, there wasn't much documentation, so it was very difficult to set things up. Okay, so now we have a lot of the information we need. So I can just set I'm going to use the standard name for the output instead of just O. So we have output, position, and clip space is vertex input. We can look in the core to see what the name is. So we want the position and clip space. And then output normal is vertex normal input dot normal world space. And the last thing we need is a UV. I do need to transform that from the model's local space into the texture space. So I'm gonna look and see how they do that here. Okay, so it just uses transform text, so it's the same function from the old shader library as it says in the comment right here. So that's easy. So output UV, transform text, input UV, and then we have to pass it to the texture, which will actually be main text. Output. Okay, so the fragment function, we take this data and then we just output a value. So what I'm going to do is just return the color of the texture. So we basically won't be using the normal for now. So do we have any errors? Unrecognized identifier v2f. Oh, I forgot to change the return value of the vertex function. Undeclared identifier main text st. Okay. Oh, right. I'm surprised it didn't set that up itself. Yeah, so it just, so this st variable, Unity automatically generates it for every texture, and it's that scaling, and actually I don't have to set it up for a noise texture, but it's the scaling and tiling variables in the material editor. If I can, yeah, right here. So this tiling and offset will be stored as the X, Y, and Z and W values here. So now what's it complaining about? Unrecognized identifier fixed for on line 58. Okay, so what does it like? Is it a float for? I guess it isn't like the fixed. This used to be a variable type for shaders, and I think it's just a different way of storing a floating point number, which I guess doesn't exist in HLSL, so that's fine. Let's look at this template to make sure I'm using the right variable type. And the fragment function. So it actually returns a half for. So we'll just go with that. And a half for is, if I don't know if you've used Java or some other programming language like that, they have a double, which is basically a higher precision floating point number. I think half is like a lower precision floating point number, but From what I've read, most compilers actually use half and floats the same, except for phones. So in phones, the half actually is lower precision than a float and also smaller, which can speed things up because that means there's less data to pass around. X2D. Okay, so this is different. Oh, this doesn't have the sampler. Okay, so I guess that's not the right function. How do they sample a texture then? Looks like they don't sample any textures here. Oh, so it all happens in this initialized standard lit surface data, because that's where it creates the albedo, which is the base color from the main texture. So I should look in the lit include file. What was the... Oh, so it's the shader library lighting. Has all of our lighting info. We won't need right now, but we will get into lights pretty soon. Okay, what was the function again? Too much code in there. So it's initialized standard lit surface data. Okay, so it's not there. Maybe it's in one of these other lit input. Oops. Okay, so it's in lit input. I guess that makes sense. So in order to read a texture, so they don't even do that here. So where's this function come from? Okay, so it comes from some other include file. They include the core, common material, and surface input. Let's look at surface input, I guess. Oops. Okay, so here it is. So it's sample texture 2D. Actually, I should have known that because that's what the function was in the post-processing shader we did the other day. Okay, so does it like that? Oh, good. So now we have no more errors. So I guess we can apply this material to these spheres and see how it looks. Okay, so if we put the model shader... Okay, well there's no lighting, so they're just going to be white right now. Also, they don't have a main texture. So let's go ahead and create something. I think I'll just have it be a flat texture for now. I don't know. I had a pink one here, so let's go with lime green. How about? I don't know why it's difficult for it to fill that in, but okay. And then export lime green. And then in our sparkle material, we'll set the main texture lime green. Okay, so now it's lime green. Obviously no lighting. So I guess we better do the lighting first while we're here. Because now that I think about it, it's gonna look pretty simple, or pretty silly without some kind of lighting. Luckily this class should help, or this file should help a whole lot. So I'm not going to worry about normal map or the light map. We will need to normalize the normal, which I guess we'll have to deal with this now because we're going to need the normal for our sorry, can't talk today for our lighting as well as the sparkles. So this is just the normal in world space, and we normalize it because as you interpolate between the different vertices on the triangle, the normal can end up kind of weird unless you normalize it here, which it makes it have a length of 1, which is important for a lot of math that we're going to do. Okay, so I'm not going to worry about light map. Okay, so the position and world space. I guess we do need this value because we need it for the view direction. Right? Yeah, so we also need the world position. Oh, okay. Yeah, that's what I was just saying. So you need the world position because you need to get the view direction right here, which is what this code is doing. Okay, well we can do that. So we just need to add float 3, position and world space as text chord 2. And I think this vertex output should already have it for us. Or vertex input. Okay, and so look here. So we want to get the view direction. So we can call this safe normalize. I'm not sure how that's different than standard normalize, but and then this get camera position world space is some function, I guess, in one of the lightweight render pipeline. 3 view direction equals safe normalize, and then input dot position world space. I'm just going to return the view direction as a color, and that way we can kind of see how it looks. Okay, so there's an error. Undeclared variable. Oh, I did a typo. Where did I do that? Oh, right here. Okay, so now you can see. I mean, that's interesting. So the view here says is 0. That doesn't seem right, but maybe it's just because it's weird in the editor. Right, because this is our position in world space that we got from here. Okay. Also, shouldn't it be the same color throughout? I'm a little confused. Well, I guess it would be a little different. Oh yeah, it would be a little different because obviously the camera is a point, and then this pixel, the view direction, points a little bit more inwards than over here. I'm not sure why this is black. Let's see. Okay, so this lighting, physically based, computes the information about the light. And I think I'll just ignore shadows for now, so let's see. I guess I will need to include the lighting variable here. Or not variable, lighting file. Alright, so let me see. Sorry about that. I'm trying to see what this BRDF data is, but it says it holds energy confusing, diffuse, and specular material reflections and its roughness. Easy to plug in your own shading function, you just need to replace lighting physically based function below with your own. Which maybe I will do something really simple, where we just multiply the view direction, or take the dot product of the view direction with the light direction. We won't have any specular highlights, but I kind of want to just do something simple for now. Okay, so I'm just going to get the main light. And let's look in the lighting and see what information is in main light structure. Might be easier to do it like this. Oh, so it actually just returns a light variable, not a main light variable. Okay, so yeah, we get the direction, and well, there wouldn't be any attenuation based on the main light. I guess if it's not a directional light. And then the color. But we mostly just care about the direction for now. Okay, so again, the light dot would be dot function on main light, and it might actually be the negative view direction. Well, I don't know, the light points towards the object and so does the view. Well, we'll just test this and see. And then the final color. Let's just call this albedo. Is albedo times light dot times main light dot color. And this will also be direction, world space. I wonder. Okay, it's just called the direction. Okay, let's see. Not convert constant float 3 to half 4 at line 69. The main light color, what is... where's the light? Right here. So the color is a half 3. Oh, so probably I need to give it an alpha value, which will always be 1. Because This is an opaque object. Incorrect number of arguments. Oh, maybe this light dot is confusing it because this is just a float. Okay, let's spread this out a little bit more. So float 3. Color. I guess I'll just make it a half 3 because they seem to like to do that. And let's just ignore the main light color for now. Oh, the issue here was that I was calling float and not half 4. Or even float 4. Okay, so that was... okay. Oh, also, yeah, I'm doing this wrong. For the light dot, you don't use the view direction, you use the normal. And I think that needs to be inverted, but... okay, that actually looks... yeah, that looks better. And then if I rotate the light around... okay, so now we have a simple shader. Okay, so let's get to the sparkle part. Alright, so we need to sample the noise texture. And then we get our random direction by sampling the noise texture. And then they offset it by half and then normalize it. And then they add the object's normal, or the vertices normal, to try to like get an offset of the normal based on the random texture. So let's do... noise is sample texture 2D, noise texture, sampler, noise texture, and then we can use the same UV here, might as well. Okay, so we have the normal. Let's see, what do I wanna... I guess we can just leave that as color. So this, let's see. Just trying to figure out how to organize the code. Yeah, so let's make the random sparkle direction. I guess first I'll offset all this by 1/2. I think I might just be able to do that, and that would give me a float 3 with all values. Okay, no, that doesn't work. Okay. Let's just see what happens if I just plug the noise in as the color. Okay, so it's just gray. That doesn't seem right. Oh, it's because I didn't hook up the noise into the material, I think. Yeah, that's better. Okay, so now we can see... well, actually, I'm not sure if you can see it on stream or YouTube, but... yeah, our noise texture is just plastered over the circles or spheres. Okay, so now next, yeah, we need to add in the normal to make it to have this noise be an offset of the normal. So I wonder, they normalize it twice. I guess I'll do that there, and then float 3. Let's do sparkleness down here. Float 3 are fixed half 3. Sparkle normal is normalize noise plus the normal and world space. And let's look at that. Okay, that looks pretty cool actually. So we can see it's mostly the object's normal, but it's peppered with the noise values. And then, okay, so we want to change the color based on the value we get by taking the dot product of the sparkle random direction and the negative view direction. And that's because the view is pointing towards the object while the normal is pointing outwards, so you want to have them point in the same direction. Or, yeah, and if they point in the same direction, then that means that the sparkle will be strongest. Okay, so half 3 sparkle color equals dot sparkle normal and then the negative view direction. And then we just add some intensity to it and then add the color. Also, yeah, I needed to multiply this UV by that sparkle scale that I set up. Okay, and then sparkle color equals pow, saturate, sparkle color, noise intensity. Okay, and this pow is just a power function, and saturate makes sure that sparkle color is always between 0 and 1. And then finally, well, let's just see what sparkle color looks like by itself, and then we can add in the normal color. Well, that's pretty cool. It's acting a bit more like a rim light, though. It feels like it should be all over the object. Let's add the color and see. So we want to return color plus sparkle color. Okay, so you can see the sparkle, but it's it's acting like a rim light, which means that it's only on objects that are like away from the direction. Did I do the dot product wrong? Well, first of all, dot product returns a float and it's casting it to a half 3, so I feel like I did something wrong there. Yeah, so this should just be half. So I guess this should be sparkle. I guess just sparkle. So again, it's acting more like a rim light. We got the view direction, and it's dot negative view direction, and then sparkle. Oh, maybe it's because the intensity is set to 0. Or actually, I think I set it to 1 here, so that shouldn't matter too much. If I increase it... Okay, that's interesting. It makes it less intense. Okay, so if we set it to 0, then that still just looks like a rim light. Which obviously isn't what's happening here, because you can see sparkles throughout the entire object. So what am I doing wrong? First of all, maybe this sparkle normal is incorrect. Sparkle map plus the world normal, and then they just normalize that, so I think that's fine. Oh. Well, I wonder if this is the issue. I don't think so, but I was normalizing this. Actually, that could have been wrong because I think it was always turning it. Yeah, I was always changing that value, so instead, noise. Oh, that was the issue. How interesting. So for some reason, if you normalize that offset, it makes it basically an expensive rim light. It's cool how at different views the sparkle effect is stronger. Wonder why that is. This should be or to be. I guess it didn't make any difference. Okay, so now let's add an actual color. So color plus sparkle. Okay, so why is that turning pink? Oh, because sparkle's negative down there? Let's see. How could that happen? Well, I guess at the view direction, well, no. Hi, Noobinator. How you doing? Thanks for coming by. Yeah, so obviously this pink is the opposite color of this green. So for some reason the sparkle or something is turning it, those faces pink. But when I turn around, it makes it seem like it actually has something to do. I don't think it's the lighting. Let's look. Is it? Good to hear you're doing well. I've been working with OpenGL, but your shaders are super basic right now. That's alright, you gotta start somewhere. I'm kind of doing a more basic shader too right now to kind of learn Unity's new rendering pipeline. Any suggestions for reading? Nothing comes up off the top of my head. To be honest, I usually just there's a few Twitter users that I like to follow because they post a bunch of cool shader tutorials, but it is more like geared towards Unity. So I'm not sure how useful that would be to you. Actually, there's a website called Cat-Like Coding that has a really great introduction to shaders. You might like that. Math should basically be the same. Yeah, that's true. Well then, yeah, I definitely recommend Cat-Like Coding, and then Twitter user Minions Art. Those are two that... Or, yeah, Minions Art posts all kinds of cool shaders, and then Cat-Like Coding, like I said, has a really great tutorial, or not really tutorial, but like a walkthrough of how Unity's rendering works, which you could probably apply to WebGL or OpenGL too. Yeah, so they have a really... This is basically how I learned how the rendering works in Unity. So. Oh yeah, for sure. You do blend wrong, but having a hard time finding resources for more advanced stuff. But Cat-Like Coding looks good. Okay, well I'm glad that that's what you're looking for. Let's see. So I'm surprised about this pinkness on the... Maybe, actually it's because I didn't saturate this dot product now that I think about it. Because it's giving me negative values. So it didn't have anything to do with the sparkle. Okay, yeah, so that was the issue with the pink. So now we can adjust scale here. Okay, so if you set this to bigger, the scale gets more fine-grained. Or set the scale larger, the noise gets more fine-grained. Okay, that looks kind of interesting, actually. Yeah, I like how when you rotate the camera, the sparkles kind of appear and disappear. I feel like this is a bit too much sparkle. Also, I think this is an artifact of the noise texture that I'm using, but sparkles always seem to appear in clusters. I don't really know if I like that too much. Don't really notice. I'm trying to see if I can notice those same artifacts in the noise texture. Oh, also the UV is also kind of strange here. But I think if I tried to stretch this out, let's just try it out and see. Scale on the Y coordinate. I want to set it to be anchored from the cursor. Okay, so if I save that, let's see how that changes. Yeah, it just kind of squishes the artifacts. We also... It's pretty cool, but yeah, that's something about it needs a little bit more work. For one, I feel like maybe it'd be nice if I could color the sparkles, which I guess wouldn't be that difficult. They're just plain white here. And here they also have a rim light around the object. The sparkles here also are pretty low res too. Let's see. I wonder if I just made a huge texture, if it would be different. Let's create a new one. This one was 1024. Let's bigger power of 2. My mind can't do math in my head right now. Let's see. 2. I'll just square it a bunch. Oh, that's a bit too much. Oh, let's... Okay, I'm not doing this right. Times 2. Yeah, 248. Let's do one more. So 8. Okay, I better not do that on stream. Let's try this. Okay, no, that's not gonna work. Well, that makes me think it's probably not the resolution of the noise. Oh yeah, and of course I can just multiply this to make it more fine-grained. I guess when you do this, you don't see those artifacts anymore, so maybe the whole issue was that I was trying to make it too low resolution. Interesting when you make it. But if you have it too high resolution, it starts being too salt and pepper. I'd kind of like... Well, yeah, because if you go too big, you're going to get to the point where the pixel size itself is bigger than the scale on the noise, so... I'll just leave it at 10. I kind of would like to be able to... Yeah, dim the color on the sparkles, and then also maybe make it a little bit more rarer. So I guess that's what the intensity does, is it by doing this power, it makes it more likely that the sparkle won't happen. But I'm interested why the sparkles seem to happen more around the rim. That seems like an error in my code, because if we think about it, the noise should be like uniform, like a uniform sphere. Unless that code is wrong, we'll have to see. And then the normals point this, like always, just point out from the face. So I don't really know why having a view direction that's a lot different than the normal would make sparkles more likely. You really tell here where the lighting is low, that for some reason when we get to where a rim light would be applied to it, meaning that the normal and the view direction are different, then there's more sparkles. I have a feeling it's probably the way that this is done. I wonder if you thought of the noise, like if I moved back into using the a tangent, then I could read this noise texture almost like a normal map and modify the normal that way. I think that might be a bit cleaner. I don't have much time left, but hey, thanks Nubinator for the follow, I appreciate it. Yeah, so I gotta switch that around. So basically what I'll do is I would just read... I guess now I'll need the... I was gonna say I'll need the bitangent, which is the third axis on the normal map, and then... What? Okay, well see, a normal map basically is just what we're trying to do here, it just perturbs the object's actual normal. So let's see, how does the code handle normal maps? Yeah, so it puts the tangent and the bitangent into the fragment input shader. Oh, this should be a semicolon, not just a colon. My editor really doesn't like that, having the space. Okay, so we have normal and then output tangent world space equals vertex normal input dot tangent world space. I hope that Blender set up the tangents for me already so I don't have to do it myself. Okay, so let's look. Oh, I barely have any time left. Hopefully, I'd like to try this out on stream at least. So yeah, the normal, see that. Okay, and then it transforms tangent to world, and then you pass this information. I wonder, this probably isn't the core. No. Is it in lit input? Oops. No. Is it in lighting? No, okay. Well, that is a shame. It's really not in core? So, let's see. Does core have any includes? It does. So probably the core common has it. Let me look really quick. Oh, here. Shader library. What was it? Not packing. Common. No. I feel like it wouldn't be in the lighting. I guess it might be. Okay. You gotta kind of do this digging yourself. So what does this include? Oh, it includes a lot. So common entity lighting, image-based lighting, and core and shadows. Well, it's not core, but it could be in shadows. We already checked common. No. What was the other one? Image-based lighting. Maybe it's in one of these. Okay, well, let's see. I was hoping to look at how that function worked, but since I'm having such a hard time finding it, maybe I can just use it to get what I want. So we have... Okay, well, what... Surface data contains... Okay, I knew all that. So what is this? Normal... I don't know what normal TS... Something... Normal and... Oh, normal and tangent space. And then... that... So maybe... if we take... the noise as being a normal and tangent space, I can just use this to transform it. Let's see real quick. I'm hoping that this will work. So this will actually just be the noise. And then we won't have this anymore. I'll take out normalize because maybe that's already included. Okay, this looks a lot more uniform at first glance. So let's just look at the sparkle now. Okay, now we got an error. Oh, because sparkle is just a float. No, it's still doing the same thing. I don't know why it's more strong around the rim light. Okay, well this is unfortunately going to take more... what am I trying to say? More work to figure out. Oh, maybe this is wrong now, actually. Hi, VFX. Thanks for stopping by. Do I hire people in general? No. Be nice if I could, but just doing game development. Well, actually, I do have a partner, but yeah, that's about it. So I have a feeling maybe this is wrong now because I already have this noise normal, and when I add it here, well, I mean, that shouldn't be too bad. Let's look at sparkle normal and see what that looks like. Okay, so one thing I can kind of see... I feel like... well, it's at least not change. Well, it actually is changing based on the view. Oh, well, it should change because... oh, well, no, it shouldn't. So why is it changing based on the view direction? Okay, well, I hate to leave it without getting a perfect perfect shader here, but unfortunately, I mean, it still looks good. Actually, now that I did those changes, it looks like it's even more of a rim light. Okay. I have a feeling it probably has something to do with the way that we transform the noise texture into a normal and then try to offset the actual object's normal based on the noise. Although I'm still surprised. I don't really know, because when we switch this back to be the sparkle normal, there's a couple things that don't seem right to me. Like, I don't know. Oh. Well, now it's not moving based on the view direction. Okay, so maybe I had put in the wrong thing, but... when I had the noise, did it change based? Okay, the noise doesn't either, so that's good at least. Okay, and it's kind of interesting that... You know what, maybe I don't need to have this sparkle normal, I can just use the noise, because the noise has basically already been changed based on the normals. Okay. Oh, I didn't actually test anything. Oops, I didn't mean to do a dot there. It's still doing it. Okay, and now it's even weirder. Okay, well, this is really interesting. I know this is gonna keep me up at night, but yeah. Maybe I'll do an update video at the beginning of tomorrow's stream, or we can continue this. I also want to, like, we're supposed to do the Twitch interactive concentration, which I would like to work more on, but I also want to fix this, so I don't know, we'll see what I feel like. But yeah, thanks everybody for coming by. I really appreciate the chatting and the follows. I'll be live tomorrow, and we'll either work more on this or one of my other projects. Just, like I said, see how I feel. But yeah, if you'd like to chat with me any other time, I do have a Discord server, and I'll put links in chat. I try to be pretty active on it, so feel free to message me. If I'm busy, I'll just get back to you when I can. Yeah, and that's about it. So I hope you all have a great day, and I'll see you later. Bye-bye.